Quantum computers sound like something straight out of a sci-fi movie. But what can they actually do? And why can't you just walk into a store and buy one? Let's find out. Imagine you're a pizza delivery driver and you need to deliver to 20 houses. What's the shortest route that visits all of them? Here's the crazy part. There are over 2 quintillion possible routes. That's a 2 followed by 18 zeros. If a regular computer checked one route every second, it would take billions of years to test them all. But a quantum computer? It can explore many routes at the same time using something called superposition. Like having multiple delivery drivers testing different routes simultaneously. Then, using something called interference, like when waves in water meet and create patterns, it finds the shortest route in minutes. So what else can quantum computers do? Creating new medicines. Scientists need to test how millions of molecules interact with each other. A quantum computer can simulate all these interactions at once, like trying on every outfit in your closet simultaneously to find the perfect match. Breaking and creating unbreakable codes. Regular computers would take thousands of years to crack certain passwords. Quantum computers could do it in hours, which is why scientists are also using them to create new codes that even quantum computers can't break. Training smarter AI. Think about teaching a robot to walk. It needs to test millions of different ways to move its legs. A quantum computer can test many strategies at once, like the robot practicing in multiple parallel universes. Predicting weather and climate. Weather involves billions of tiny interactions. Air pressure, temperature, humidity, wind, all affecting each other. A quantum computer can run countless weather scenarios simultaneously, giving us more accurate predictions days or even weeks in advance. But here's the thing. Quantum computers are terrible at everyday stuff. Watching YouTube videos? Your phone does that perfectly. Playing Minecraft? Your laptop is built for that. Writing an essay? Your regular computer handles it instantly. A quantum computer would struggle with these simple tasks. It's like using a microscope to watch a movie. Sure, it's powerful, but it's the wrong tool for the job. Think of it like this. A quantum computer is like a Formula One race car. Absolutely amazing on a racetrack for that specific purpose. But completely wrong for getting groceries. It can't fit in parking spaces, it needs special fuel, and it's way too complicated for a simple shopping trip. Your regular computer is like a family car. Perfect for everything you actually need to do every day. So why doesn't everyone have a quantum computer? Because they're incredibly hard to build. Let me show you why. Problem number 1. Extreme cold. Quantum computers need to be kept colder than outer space. We're talking negative 459 degrees Fahrenheit. That's colder than anywhere in the universe. Why? Because qubits, the quantum version of computer bits, are incredibly sensitive. Any heat makes them lose their quantum powers instantly. You need a refrigerator system bigger than your bedroom just to keep the tiny chip cold. Imagine needing a refrigerator the size of your house just to keep an ice cream cone frozen. Problem number 2. Super fragile. Qubits are like soap bubbles. The tiniest disturbance pops them. A vibration from someone walking nearby, boom, qubits lose their information. A stray radio wave from a phone, crash. Even cosmic rays from space, billions of miles away, can destroy quantum calculations in milliseconds. It's like trying to balance a pencil on its point during an earthquake while someone's blasting music next to you. Problem number 3, errors everywhere. Because qubits are so noisy and fragile, they make mistakes constantly. Here's the wild part. You need about 1,000 physical qubits working together just to make one reliable, logical qubit that doesn't make mistakes. Your regular computer bit, it just works every single time. A quantum bit, it needs 1,000 helpers doing error correction constantly. Now, here's the exciting part. Today's quantum computers are like those room-sized computers from the 1950s. They work, but they're huge, expensive, and imperfect. Back then, only universities and governments could afford computers. They cost millions of dollars and needed their own building. But look at our progress. In just 25 years, we went from 2 qubits to over 1,000 qubits. We're getting better at building them, keeping them cold, and fixing errors. Tech giants like IBM, Google, Microsoft, and Amazon are racing to build better quantum computers. It's like the space race, but for computing. And here's the coolest part. You can actually use a real quantum computer today. These companies let students and researchers access their quantum computers through the cloud, just by connecting from a regular laptop. You send your problem through the internet, the quantum computer solves it and sends back the answer, all while staying in its super cold environment. In the future, you probably won't own a quantum computer sitting on your desk. Instead, when you have a really hard problem, like optimizing a delivery route or designing a new medicine, you'll send it to a quantum computer in the cloud. It'll be like calling in a superhero for the impossible tasks, while your regular computer handles everything else. Quantum computers won't replace regular computers, they'll be teammates, each doing what they do best. Together, they'll help us solve problems we can't even imagine today. This is the Knowing Lens, where we take the most mind-bending, complex science in the universe and explain it so simply that a 10-year-old could teach it to their friends. No boring lectures, no confusing jargon, just pure, wow, that's how it works? If you thought quantum computing was wild, wait till you see what's coming next.